So for this first one, I would just encourage you to memorize the derivative of square root. Does anyone remember that? Or you got out your bubble sheet? How to put it on there? Go ahead.
1 over 2.
Good. It's 1 over 2 square root. But since there's an 8 there, it'll just be 8 over 2 square root. If you just memorize that one, you won't have to deal with the 1/2 and the -1/2 and all of that mess, which you certainly can. It is up to you, but I'm just encouraging you to maybe memorize that one. It's 1 over 2 square root. There was just an 8 there, so it's 8 over 2 square root. This one I'm going to write off to the side. It would be -3x to the what? Like if we rewrote that. -5, like to the -5th. The fractions come from the roots. So if you had like a 5th root, it would be to the 1/5. All right, so let's do the power rule for that. If you multiply that down, what do you get? All right, so it'd be 15x to the, careful. Good. Okay, and then we're just going to clean that up. So you can reduce the first term. 8 over 2 is 4. And then how would you rewrite this second one? Yeah, 15 on the top, good. X to the 6th on the bottom. Cool. What rule do you need for this one? Product rule. Okay, so I'm going to start all the way over here. Try to write little. It's going to be about this long. Okay, how does product rule start? The first one. Yeah, in your mind, you want to call them the first thing and the second thing. All right, so it'll be 2 minus x cubed. Hey, looks like you just recopied it. Sure did. Derivative of the second. So I'm going to cover all this up. You want the derivative of just this part. Well, what happens to the 4? Yeah, that's gone because it's a constant. X is a little tricky. That gives you what? Good. 1 because it's 1x to the first. All right, plus. Good. 15x to the 4th. Perfect. Close parenthesis. Then what? Yep. Add. So plus the second thing, the second function. So just copy all of that down. Times derivative of the first thing, which would give you what? -3x squared. Now, I believe in my heart that if I made you distribute all of that to each other, you could do it. I want you to just stop for your quiz. I'm assessing you on the product rule, not can you distribute things. Do you get what I'm saying there? I want to assess you on the calculus, not the algebra. So we're going to just leave all these alone. Okay? So that's it. Walk away. Please don't anybody distribute it. Because if you do, I'm going to have to set aside my answer key and stop what I'm doing and work the whole thing out to figure out if yours is right or not. And when you inevitably drop a negative sign, I'm going to have to mark it wrong. So can we just agree to stop there for my sanity? Okay, thank you. All right, how about number 3? That's just a regular old power rule. Yeah, 1/4 of 20 is 5. So 5x to the 19th. What happens to this? Yeah, goes away. It's a constant, so it's gone. All right, and what rule do we need for this one? Quotient rule, because it's a fraction. If you remember where it starts, you will probably get the rest of it, because it's kind of one of those things where once you get the ball rolling, the rest of it's going to flow. Where does it start? Yeah, the denominator. So just copy that. Then what? Derivative of the numerator. That would be 3x squared. Good. And then this one is good. Negative minus the first one, or the numerator, times 4, derivative of the denominator, over denominator squared. Good. And again, I would like for you to just stop there. I'm trying to assess you on the quotient rule, not can you distribute things. So we're going to just leave them alone. Now, these ones on the back have some words, so you're going to have to like read and know what your vocabulary is. Instantaneous rate of change means derivative. So you're going to get the derivative and then do what? Plug in 3. Good. Okay. So f prime of x. What rule do we need for this? Okay, so same thing we just did. It's going to be the denominator. All right, so this one is denominator times derivative of the numerator, which weirdly would just be 1. Now, you will get to a point eventually later in the year where I would be like, it's okay to drop that 1. Right now, I'd kind of like you to put it because you're just learning these patterns, and that's part of the pattern. So technically, I can't mark it wrong if you don't put it, but I feel like you should because you're just learning. This is new to you. All right, minus what? X plus 1, good. And then derivative of the denominator, 3. And then it's over denominator squared. Now, I did bring this up last time, and I will have to mark this wrong if you do this. If you put an equal sign and then start plugging in 3, do you remember what kind of error that is? It's not a copy error. Do you remember what that's called? It is a linkage error because you have linked together two things that are not equal. So you can do one of two things. Just don't put an equal sign and start plugging in 3. Or what I kind of like better is if you write f prime of 3 equals and then start plugging in 3 because you're showing me, you know, this is the derivative and then this is the derivative at 3 specifically. But you can't link them together because they aren't equal. All right, now we're just going to plug in 3. 3 times 3, 9 minus 7, 2 times 1 is 2. Minus 3 plus 1. 4 times 3, 12 over, that would be 9 minus 7, which is 2 squared, 4. Let's go ahead and reduce that though, because that's not going to be too difficult and we don't want to lose our skills. That would be, what, negative 10 fourths? Perfect, negative 5 halves. Let me have you reduce the fraction. We can reduce a fraction. I think that's reasonable. All right, that's all it got asked for. So let me clarify this because this did happen to some of you on the last test. If all it asks for is the instantaneous rate of change at 3, that's all you put. Because some of you kept going and wrote a whole equation. The reason I have to take off for that is it's a direction following issue. I don't know if you understood what the direction said, so please don't go further if you're not supposed to, all right? Find slope of the tangent line. That means derivative at 8. So if you even want to just go ahead and set it up, we're going to find f prime and then we're going to plug in 8 separately. Like if you want to even just do that, get it set up. This one is fun with fractions, right? You're going to multiply the 5/3 down. 5 times 2, 10. So it will be 10/3 x to the power what? You have to subtract 1. So good. You guys are good with fractions. Like that is solid, which makes my life so much easier. So I don't have to stop what I'm doing and teach fractions. Now, I would go ahead and rewrite it as a root. I know the problem wasn't that way, but we have to plug in 8 and our lives will be a whole lot. And does anyone know 8 to the 2/3? I would go ahead and write it as a root. Do you remember what goes where? If not, I'm going to tell you, but do you remember where the 2 goes and where the 3 goes? It's a cube root and then x squared. I know it's one of those things where one of them goes in one place and one of them goes in the other. You have to remember the denominator is the type of root it is. All right, now we're going to plug in 8. 8 squared, 64. Cube root of 64 is 4. Are y'all still with me? And then 4 times 10, 40. So you have 40/3. I'm going to say that again because that was a bit of a journey through that. 8 squared is 64. Cube root of 64, 4, and then 4 times 10, 40. So 40/3. All right, and then this one says write the equation. You need 2 things. What do you need? A point and a slope. Good. You're going to have one part of that. The x is 25. How do you get the y? Yeah, plug it in. All right. Square root of 25. 5 times 6 is 30. 3 minus 30, negative 27. Good. We made it. All right. Slope comes from derivatives. So we're going to need to find f prime. The 3 is a constant. So what happens to that? Yeah, it's gone. I'm going to just cover it up. All right. If you memorize derivative of square root, you'll be so much better off. It is what? 1/2 square root. But this one's going to be negative 6/2 square root. Just whatever number is there will go in the numerator. It like the coefficient is just there. It's just there. All right. And to get our slope, we're just going to plug in 25. So square root of 25 5 times 2, 10. So -6/10, which would be -3/5. Good. Perfect. You guys are good with fractions. That is awesome. And then you just put all that together and write your answer. It'll be y perfect equals -3/5 parentheses. Can someone give me an example of a number we could estimate using that tangent line? If you were asked for an approximation, like what's a number we could plug in to approximate? Like 24.9, 24.8, or on the other side, like 25.1, but something really close to 25.